Hey team, I'm Mike, this is the Code Dojo, and today we're going to talk about the name inverter kata. In name inverter, what we're going to do is write a program that, given a string which represents a name, will return that same name in last comma first format. So given a name like John Smith, it should return Smith comma John. Now there are a couple tricks to this. The first being that we're going to want to deal with honorifics, things like Mr. and Mrs. We're also going to want to deal with what are called post-nominals, so senior or the third, PhD, things like that. We're also going to want to handle the case where there's too much white space in the input string, so we'll trim that up to make sure that the output always has consistent spacing. I really like Name Inverter because it gives you the opportunity to practice a really important skill, and that skill is refactoring. Now, when we say refactor, what we mean is to take an existing piece of working code and manipulate it in such a way that we don't significantly change the behavior of that code, but we do significantly change the form of it, that is, the way that it looks. There are several reasons why we might want to do this, but let's talk about just two of them. The first is for readability. Good software engineers know that you get in and make the quickest, dirtiest change that you can in order to get something working. But after you've done that, and before you deliver, you refactor the code to make it as easy to read as possible. That includes things like changing variable names, extracting variables, extracting methods, reordering the order of the methods, pulling out new classes, all of those sorts of things to help your future self and your teammates be able to read and understand what the code does. Refactoring also comes into play when you need to add a new feature to an existing piece of code, but it's not obvious how to do that. In that case, really good software engineers will take the existing code and refactor it such that adding the new feature becomes trivial, and then they add the new feature. Name Inverter is a great kata for practicing both of these refactoring skills. So let's dive in. All right, so as always, we're going to start this with a test. So remember that our first test should be the most degenerate case that we expect to encounter with this program. And in this case, like in a lot of cases, that's going to be what if the input is null? So my method is going to be called invert. And what if we're asked to invert a null? So what do? We can talk about this more some other time, but for me, I try to not tolerate nulls in my programs. So I often will handle nulls by simply throwing null pointer exceptions and just failing out. So that's what I'm going to do here. Invert null should throw a null pointer exception. Okay, so since we're throwing, we don't need to assert anything. I'm going to call the class Name Inverter. And like I said, the method is going to be called invert, and we're going to see about inverting null. And what I want to happen is to get a null pointer exception, like so. All right, so obviously I don't have a name inverter class. Let's go ahead and create that in the main directory. There we go. Okay, and I also don't have an invert method, so let's create that. Now it needs to return a string, and it's going to be given a string, and let's call this variable name. Okay, so it doesn't compile yet because this isn't returning anything, so let's just jump right to throwing a new null pointer exception, which should pass the test, and it does. All right. So we can move on to the next test. So the next most degenerate case, if it's not null, is going to be an empty string. What if you're given an empty string? How should we behave? And I'm okay with handling empty strings. I don't feel the need to throw an illegal argument exception or anything like that. Let's just return an empty string in that case. So invert empty string should return empty string. Okay? Name inverter, invert. The empty string is empty string. Okay, that doesn't work, obviously, because we always throw a null pointer exception, but that's not what is expected here. So let's do a little refactoring and say, well, okay, so if name is null, then throw the null pointer exception. Otherwise, return an empty string, and that passes the test, so we're done there. Now, I did say that we want to handle kind of extra white space. So let's start doing that right here from the beginning and say, well, what if you're given a string that just contains some white space? Well, we just want to trim that white space and return an empty string. So this actually passes, and the reason is because we've hard-coded a returned empty string. So that's what was expected. That's what we got. But I'm going to leave this in here, even though it didn't produce any test failures yet, because I don't want to regress on this in the future. I want to make sure that given some kind of white space that we're going to get an empty string back. So I'm going to leave that there. Okay. Next. Okay, the next most simple case is going to be, what if you're given just a first name? How do you invert John, for instance? Well, I think the appropriate way to handle that is going to be to just return John with no last name. So invert first name should return first name. Okay? And we'll just use the case that I just said. So invert the string John is John, like so. All right. Well, first of all, so I guess what we're going to be doing is pretty much just returning the string that was passed in. So instead of returning an empty string, let's go ahead and return the parameter that we were given. Now, this works in a couple of the cases, but that one with the random space does not work, which is why I said that I wanted to keep it. So, so we can fix this really trivially by simply trimming this here. Now, I sometimes forget to do this, but at this point, we actually no longer need this. And the reason is because if name is null and we try to call trim on it, it's going to throw a null pointer exception. So we don't need to actually do this check for null anymore. So we pull that out. As you can see, all the tests still pass. So that's true, and this is what our solution looks like right now. All right, now I'm going to do something similar to what I did with the last test and throw some random space around the name John here for the same reason, that we don't want to regress on this fact that given a first name with some random space around it, we want to return just the first name without that space. Next test. Okay, invert first, then last. And this is kind of the core of this program right here. I kind of imagine that most of the time this code would be used for, given a first name and last name, return last comma first, right? So this should return last comma first. Okay? Name inverter, invert John Smith is Smith comma John. Okay, obviously that doesn't work. And it's not obvious how we can just add on the last name to this. So why don't we make a place where we can add it on? So what I'm going to do is I'm going to pull this out into a variable. And then I'm going to say, well, let's do string format, and we're going to have the string and then this variable first. So this still works just as well as the old code did. It doesn't solve the new test yet, but all the old tests pass by doing this. Okay, well now it's pretty obvious where I should add the new code. We should add a comma here and a second string, and this should be the last name. Okay, now I don't have a string like that, so let's just throw this in here as a placeholder. And figure out how we're going to separate out the first and last name. So this should be pretty obvious. We'll use the split method on string, and we'll split on a space, right? There's one space in between John and Smith, so if we split on that space, then we should get an array that contains the first and last name, and then we can just allocate those parts of the array into the appropriate places of our string.format. So let's do a list of strings, which I'm going to call name parts, and we'll use New array list, and the string name. I still want to trim it just like it used to be trimmed, and then split it. And we'll split on a space, like I said, and there. Now we have our name parts. You'll notice that I went straight to using a list instead of using the array directly, the array that resulted from splitting the string. And that's just good practice. You should use array, or you should use lists when you can. A lot of people, I guess for performance reasons or something, try to use arrays until they absolutely must use a list. But this just doesn't really make sense. Just use the lists. Okay, so like I said, the first name now we know is in name parts get 0, and the last name is in name parts get 1. And all right, so now our new test is now passing, which is great. But we did regress on some of the old tests. And the reason is because not all inputs have two parts. And so when we call get1 on those strings, like for instance just the first name or the empty list, then we're going to get the index out of bounds, exception. So we'll need to do a check before we do those gets and say, look, if nameparts.size is less than 2, meaning there is no last name, then let's go ahead and just return the first name, which is nameparts get 0, like so. All right, now let's continue with this trend of adding extra white space by throwing in some white space in between the first and last name. And as you can see, that fails. The reason that fails is because our split here is splitting on just a space. That's pretty easy to fix. Split can work with regular expressions. So we'll throw in the regular expression here for effectively any amount of white space is basically what this means. So now, no matter how much white space we have in between the name parts, that'll get stripped away when we break it into parts. So that works. Tests are passing. All right, let's do some refactoring because I don't know about you, but this is getting hard to read, in my opinion. So the first thing I'm going to do is this regular expression. Regular expressions are like one of the most cryptic things to read and understand. And this is actually not too bad of a regular expression, but they can get long and complicated and hard to read. So I always try to help my poor readers by giving these things nice, clean names. So let's pull this out into a method called any amount of white space. White space. Okay, like so. Now, already I would say, this is an odd place for this method to live. This class is called Name Inverter and has a method called any amount of white space, which returns a regular expression. That's not really a very sensible place for that to be. So I'm going to go right away and break this out into a new class, which I'm going to call regular expressions. And this would just be the place where I put the methods that have nice names that describe what these regular expressions do. And because I imagine that in any given program where you're doing string processing, you're going to have a whole bunch of different regular expressions that you're using. So they should all live together in a class that's well named, like regular expressions. So this is going to need to be public because we got to call it from outside of the class. And we're going to need to now reference it like so. Regular expressions dot any amount of white space. Okay. So yeah, that looks good. Now I'm going to take this piece, this piece here, and this is really like the core of this program, right? We find the first name and the last name, and we invert it, right? So I want to take this and I want to kind of highlight it and move it out into its own method, which I'm going to call invert. And so this kind of moves all of the kind of exceptional conditions and the work that we did to get to this point away from what's really important, which is just this piece. So so I'm gonna kind of communicate that to the author by sectioning it off from the rest of the logic. The last little bit of refactoring I want to do is this hunk of code right here is rather wordy. Lots of method calls embedded inside one of another, and you have to kind of understand all the details in order to get the big picture, and I don't like that. So let's just tell the reader what the big picture is, and that is that we want to break into parts ignoring white space. There we go. That's much better. All right. I think that's good for now as far as refactorings go. So let's move on to our next test. And in the next test, what we want to do is move on to the honorifics. Let's do honorifics. So honorifics, first, last. And if you recall from the introduction, what we want to do with honorifics is just drop them. We don't need to include them in the output string at all. So given a string that is an honorific followed by a first and last name, then we just want to return the same thing we would if we were given a first and last name. So should return last, comma, first. Name inverter, invert. And so an honorific like Mr. John Smith is, again, Smith, comma, John. Like that. All right, so obviously that doesn't work. So how are we going to make this change? Well, I think what I'm going to do is wrap this in a method call called without honorifics. And what that's going to do is it's just going to check to see whether or not this name parts list includes any honorifics. And if it does, we'll just take them out of the list. We'll just drop them. And then the rest of the program should work the same as it did when there were no honorifics in the input string. So how are we going to tell if there's honorifics? Well, we could tell if there's honorifics by just checking the first element in the list to see if it is an honorific. Right now, the only honorific that we need to support from the tests is Mr. So let's just say if Mr. equals nameparts.getZero, then let's remove nameparts.getZero. And that passes. All right. But we need to handle more than just Mr. So why don't we do one more case and say Mrs. Mrs. Jane Smith should return Smith, comma, Jane. All right, so obviously that fails. All right, so to fix this, the first thing we're going to do is pull out, I want to pull out a separate method that is going to deal with figuring out whether or not something is an honorific. So I'm going to create this temporary variable, which is why I'm choosing a name like S, because it's just, I'm going to get rid of it in a second. And I want to call the method is honorific. There. So given some string, this method is going to return a Boolean, true if it is an honorific, false if it is not. Okay. Now, I'm going to. This is the same thing that I saw when we pulled out this any amount of white space for the regular expressions. Is that this class is a strange place for a method called isHonorific to live. It doesn't seem to share any kind of commonality with the other methods in this class, so it's probably not the right place for this to live. I can imagine other classes needing to know this, so I'm going to go ahead and pull this one out into its own class also. And that class I'm going to call Honorifics. All right, so this is going to need to be public then. And to reference it, we're going to need to do honorifics dot is honorific, like so. All right. Now, getting back to what we were working on here, which is adding misses. So I think the strategy that I'm going to use is I want to have a list of all of the possible honorifics, all the known honorifics, we'll say, and just check to see whether or not the given string is in that list. So let's pull this out, and we'll call it known honorifics. But it shouldn't be a string. Let's go with a list of strings. In fact, an immutable list of strings. Immutable list dot of, like so. And now we don't want to check to see whether this list is equal to the given string. We want to see if this list contains the given string, like so. All right. Now, all of the old tests still pass, right? We can still handle all of the cases except for this one new test. But now it's very obvious how to make the new test pass. We simply add misses to this list, and it passes. Okay, one more little bit of housekeeping refactoring here, and that's that I'm going to just pull this out into a constant. Like this, and then inline this, and that's good enough for now. Okay, so we're not going to go through any more honorifics. Now that we've done two, it's very obvious that any other honorifics, miss or ms or whatever that you want to add, you just add it to that list. So let's move on from there. New test. So now it's time to deal with postnominals. So given first, last, postnominals, that should return last, comma, first postnominals. So basically, we're going to leave the postnominals where they were. Okay, so name inverter, invert John Smith Sr. Oops. Is Smith, comma, John Sr. There. So obviously that doesn't work, but it's not too hard to see where the change should be made. It's actually very similar to when we added last. It goes right here. So let's just throw in an empty string for the moment. So we're going to add a new string to this format call here, and it's going to be postnominals. But oh wait, we regressed on some of our tests. And the reason is because of this space that we added right here. This is just an empty string, so even if there are no postnominals, that's not going to change anything. But this string does. We can fix that by simply trimming the result here. All right, we've fixed all those tests that we regressed on. Now, let's move forward with the postnominals. So let's say, well, first we need to check whether there are postnominals or not. So if nameparts.size is greater than 2 at this point, because remember, we've already stripped out all the honorifics. So if nameparts.size is greater than 2, then there must be postnominals. And for now, our tests only have one postnominal in it, so let's just deal with one postnominal first. That postnominal is at the end, so it's at, or actually let's do this, let's do plus equals nameparts.get2, and that passes. All right, so we do need to deal with more than one postnominal though. So let's say that John Smith Sr. also has a PhD. So now we've got two postnominals, which our code doesn't handle yet. So let's take this and make it a little bit more generic so that it can deal with any number of postnominals. And we'll do that by switching the for or sorry, switching the if statement to a for loop, and saying for all of the name parts in the sublist that starts at 2, which would be the position of the first postnominal, and goes to the end of the list, which has that name parts.size. Okay, so now rather than getting to in that case, what we want to do is the name part, and we need to put spaces in between each of the name parts. That works. Now we can support any number of postnominals. So we've kind of messed with the nice structure that we had going on here, where we had first, last, postnominals, all kind of with their own one-liner, and we've added all this detail into something that was a very nice high-level core piece of logic to our algorithm. So let's fix that by just pulling this out into a new method and saying find and merge postnominals. Find because we're going to figure out which parts of that name part list are the postnominals. Merge because we're not returning a list of those parts, we're merging them all together into one string. So find and merge postnominals. Okay, and I think that looks good. So at this point, I think we've dealt with all the requirements. We've gotten the degenerate cases of null and empty string. We've dealt with first names only. We've dealt with first and last. We've done the honorifics and the postnominals, and we've dealt with all the white space issues, whether on the outsides or in between the name parts. So I think we're done. Let's just write a acceptance test to see how it all works together. Name inverter, invert, and we'll do something absurd like Mr. John Smith Senior PhD. Okay, and so applying all of our rules, this should be Smith John Senior PhD. And it works. So we are indeed done. So that's Name Inverter. Like I said, it's pretty heavy in refactoring on the production code side, both in terms of making code easier to read and also making it easy to add new features. That's what I like about the Kata. This is one of those skills that's really important to learn and master through practice. It's a differentiator between those that are really good software engineers and those that are just programmers. Again, I'm Mike. This is the Code Dojo, and I hope I see you soon for another Kata.